Welcome everyone. My name is Kabir Nasir Aliyu. I am here to present how to simulate experiment 8. Here is the procedure that we will use for this experiment. So let's start. This is the workspace of the multisim. In this experiment, we need the function generator here. We also need the resistor. We can find it in basic. Here is the resistor. We need the capacitor, and we need the inductor. So we need also the ground from source. So now all our components is complete. The capacitor we need is 0.022 micro. 0.022 micro. 0.022 micro farad. You can change the orientation of the capacitor by clicking on it and press Ctrl R. The value of the resistor we need is 1.5 kilo. Click OK. So now we can change the orientation of this function generator by clicking Ctrl R as well. Then we click right click, we flip it horizontally. Then we connect our components. To complete the circuit, we connect all the components to complete the circuit. Click here. So now our circuit is complete. What next? Connect the circuit of figure 2, adjust the voltage source to 5 volt peak. Then we go back to the function generator, we double click on it, we change the voltage to 5 volts. 5. And change the frequency to 20 kilohertz. We change this to kilohertz. Then the third procedure said use the oscilloscope to measure the magnitude and pace of all voltages and record the value in table 2. So we find the oscilloscope here. This is the oscilloscope. The oscilloscope has two terminals. Terminal channel A and channel B has two channels, channel A and channel B. The positive terminal of channel A is connected to the source, while the negative terminal of channel A is connected to the ground. The positive terminal of channel B is connected to the first terminal of the resistor, while the second terminal of channel B is connected to the second terminal of the resistor. So we simulate our circuit using run button, and then we double click on the oscilloscope to view the response of the circuit. As you can see, the signal is jammed. Then we can stop it, and we can change the time scale here so that we can easily view our signal. Here is the time scale. We change it. As you can see, the color of both the waveform is red. We can change the color of the waveform by clicking on the positive terminal of channel B, and then we click right click we go to the segment color and we change it to green, to the required color, but it has to be different as the other one, so that you can clearly differentiate them. Then we run again. As you can see now, our signal is different. So now what next is to find the magnitude and phase shift as required in this table. Firstly, let's find the magnitude, or let's find first the phase shift. The phase shift can be found using this formula. Phase shift theta is equal to 360 times time shift all over period. The time shift can be found using this horizontal line. This horizontal line we can increase by dragging the side of this. Using this horizontal line, we have this horizontal line. There are two. There are two. So once we click on it and we drag, you see it is moving in the red signal. So we take it to the beginning of this red signal along the time of this. As you can see, we bring it here, and while you are moving this line, there's a changes that is happening here. These values are changing in T2, because here is 2. You can see here is 2, so it is changing in T2, and here is 1, so in T1 it is changing. But the difference between them is given here, which is our time shift. So we have to move also the T1 along the second signal. But for it to be moving along the second signal, we have to click on the second signal, which is the green one. We click on it, you will see there is a changing. Then we drag the horizontal line that has 1. We drag it, as you can see. We take it to the place where it caught the time axis. So you see, this one we left it after we set it to here. Then we change the horizontal line to be on the green signal, so that we can easily drag it and take it along the time. So as you can see here, we have minus 4.595 microseconds. So our time shift, which is tau, is what? Minus 4.595 microsecond, and the period can be found using 1 over the frequency, and we know that the frequency is 1 over 20 kilohertz, which is the same thing as 5 times 10 to the power of minus 5. So we can find the phase shift, which is the same thing as 360 multiplied by minus 4.595 microsecond divided by 5 times 10 to the power of minus 5, which is the same thing as, when we use our calculator, we have 360 times minus 4.595 micro divided by 5 minus 5. We have minus 33.084 degree. When you calculate using the theory, that is the theoretical value, you will find it is around minus 30 point something. But maybe because of some errors, parallel errors that happen here while we are trying to shift this. But let's go back again and see if we can make some changes that will decrease the error. So you can see once we click on the red signal, it will change. So you can use even this button to shift it. So you are in the second horizontal line, so you can use it, you can shift, you can see it is moving, it is moving, it is moving. Now it's decreased a bit, which is minus 4.324. So if we assume it is minus 4.324, which is minus 4.324 microseconds, let's see what we can get. Minus 4.324 microseconds. What do we have? You see, it's decreased because we try to reduce the error here. So now it become minus 31.13 degree. Minus 31.13 degree. So we find it, then we come here and record it. We have minus 31.13 degree. So try as much as you can to decrease the error so that it can be approximated toward 30, around 30, which is the actual value. But when you do it in your theory part, you will find it. So try to make the error so that it will be much different with the theoretical value. So you record here 31.13 degree. What is the magnitude? So to find the magnitude, watch out. You have to click on the green one because you are interested in the green one, and you shift the second one, which is this. You shift this, the T2. You see? Let me see. You shift the T2. As you can see, you go to the high peak value here. So this is your what? The voltage you have in the channel B, which is 4 point something. So when you do your theoretical part, you will see you have something around this 4.276 volts. 0.276. So now I finish with the resistor. So let me go back to the inductor. To work on inductor, we have to remove our terminals from the resistor, move to the inductor. So I can click on it and then press delete to delete it. Then I will connect it to the inductor, the positive to the first part of the inductor, then the negative will be taken to the second of the inductor, and we double click, we right click on this positive terminal so that I can change the color to green. Then press OK. So now I press run button to run circuit. Then I double click on this. You see, I have my signal here. I have my signal here. In the inductor, we know that the voltage is leading the current. As you can see here, the voltage is leading the current. It's coming first, then the current is coming. That is the source is coming. So the voltage is leading the current. So to find the phase shift and the magnitude, we can find it as here. The phase shift can be found as the same way we find it in the case of resistor. Firstly, we have to find the time shift. Using this button, we click on the red signal, we move this to the place where it begins here. It cuts the time axis. See it? Because it is the second horizontal line, so we can shift it here if we like. Can shift it here. Try as much as you to get it perfect. Then we click on the green one. Then we shift this the first one, which is this, the place where it cuts the time axis. You can use this button to shift it a bit. So you have what do you have? You have 8.108 microseconds. You have 8.108 microseconds. So you come and say theta L in the inductor is something as 360 times 8.108 microsecond divided by 5 times 10 to the power of minus 5, which is centimeters. 360 times 8.108 microseconds divided by 5 minus 5. We have 58.38 degree. So you come here and write 58.38 degree. How to find the magnitude? Then we have to shift our signal. We have to shift our horizontal line so that you can get the magnitude. Shift our horizontal line. We have like 3.6 in channel B. We are always considering the channel B. Then you come and record it. We have 3.6. We have 3.6. For the capacitor, in the case of a capacitor, you have to remove this positive terminal and connect it here, and the negative terminal connect it here. Then you simulate your circuit. You find the time shift, calculate the phase shift, find the phase shift and record it. Find also this magnitude as the way we find it in the case of resistor and inductor, and you record here. So I will leave this one for you to do it by yourself. Then you find the current using this formula, V over R. That is this voltage divided by this. you know that B is the same thing as, you have the theta here divided by R. So you will see the theta, the phase that you get is the one that you record here, and also the current that you find the magnitude here and write it here. So this is how you can simulate this circuit and take your values and record it in this table. Then you find your error using simulation minus the theory over the simulation times 100%. You take the absolute of this. So after this, the next thing to do, let's clear this. You need to draw the circuit in frequency domain. The circuit in frequency domain, as the way we have it, you have the capacitor here, you have your source as it is given here, but now it will be in complex value here, complex value, that is the reactance of this inductor, and then this is the reactance, the value that you get as the reactance of the capacitor, and then here you have the value of that. The phasor diagram should be something like this. You have the current here, you have the voltage here, then you find you have to read something about the phasor diagram, but I'm just giving you this as a hint so that you will know what you are going to do. And then you find it after you read some stuff, you get more information about the phasor diagram, then you write it correct. So when you come to the question, you have to answer this one, and also you have to answer this one by yourself, also this one. So in conclusion, this is how we can simulate the circuit in the frequency domain, and you need to attach your screenshot of your simulation in the report. While you are taking values in the resistor, you have to show the screenshot of the oscilloscope, how you take it. After you connect the circuit, your channel B to the inductor, and you energize your circuit, you have to show the screenshot of the oscilloscope. And also after you connect it to the capacitor, you have to show the screenshot of the oscilloscope. This is the end of this practical. Thank you.